Hi, Assalamualaikum. My name is Mankarnisa Syairah binti Wan Abdul Manan. Today I want to present about atomic mass unit AMU. An atomic unit AMU is defined as precisely 1/12 the mass of atom of carbon-12. The carbon-12, like C12 atom, has 6 proton and 6 neutron. It is a nucleus. The atomic mass is a weighted average of all the isotopes of the element. Mass of individual atoms are very small. Using a modern device called as a mass spectrometer, it is possible to measure such as minuscule masses. 1 AMU equal 1.60054 times 10 root negative 24. An atom of oxygen 16, for example, has a mass of 2.66 times 10 root negative 23 gram. While comparison of masses measured in gram would have some usefulness, it is far more practical to have a system that will allow to more easily compare relative atom mass. An atomic mass unit is defined as a mass equal to 1/12 the mass of an atom of a carbon-12. The mass of isotope is any element is expressed in a relation to the carbon-12 standard. I choose to show you guys the copper is 69.17% and Cu63 with a mass of 62.1396 AMU, and the rest of Cu65 with a mass of 64.9278 AMU. Okay, let's see the example, copper 63 and copper 65. And I got the find the atomic mass AMU. And let's see the conceptual plan relationship, isotope masses and isotope fraction, and got an atomic mass. Let's see the solution atomic mass of like with times with the isotope mass and isotope fraction. And let's check the average is between the two masses closer to the major isotope. So next is a relative atomic mass. The symbol is AR. Or atomic weight is a dimensionless physical quantity defined as the ratio of the average mass of atoms of a chemical element in the given sample to the atomic mass constant. The atomic mass constant, the symbol is Mu, is defined as being 1/12 of the mass of carbon-12. Okay, this one is a formula of a relative atom mass. It's a mass of one atom of the element, and multiply with 1/12 mass of one atom of a carbon-12. I would like to show you the example of chlorine, naturally exists of two isotopes, chlorine 35 and chlorine 37. Okay, so let's see the formula. To calculate the relative atom mass AR of the chlorine, we need the total mass of atom multiply to total number of atoms. So let's see the example. We got 35.5. Then we need to take the one decimal place, and notice that answer is closer to the 35. That is 37. So because the chlorine is 35 isotope, is much more evident that the chlorine is 37 isotopes. And the next is, let's talk about relative molecular mass, RMM. Okay, the relative molecular mass of a compound is the sum of the relative atom mass of atom present in the formula to mass of one atom of the carbon-12. If the individual mass of all the atoms in a formula are added together, you have to calculate the relative formula mass. Okay, so let's see the formula RMM. Is a mass of one molecule per formula unit of a compound and multiply with 1/12 mass of one of atom of a carbon-12. And that's how to calculate the relative molecular mass. So let's go to the topic molar mass. Okay, the molar mass of the chemical compound is defined as the mass of a sample of the compound divided by the mass of a substance in the sample measure of in mole. The molar mass of the substance is numerically equal to the relative atom mass. So let's see the formula mass. Okay, number of atom of first element in chemical formula times atom mass of first element, and plus with a number of atom of second element in chemical formula, and times with the atom mass of a second element. So let's see all of element molar mass, and this is not all but in half, and I want to show to you guys is a named chemical element like hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, and oxygen. Okay, this is how atomic mass look, and this is we get from the formula, and this is how they look. And that's all for me that I want to show with you guys with this topic of the mole concept of 2.1. Okay, thank you.
Assalamualaikum warahmatullahi wabarakatuh. So the mole concept. The mole is amount of unit similar to familiar unit like pair, dozen, cross, etc. It provides a specific measure of the number of atoms or molecules in bulk sample of matter. A mole is defined as the amount of a substance containing the same number of discrete entities. The mole equals to number of particles equals to the number of atoms in 12 grams of C20. One atom of C20 weighs exactly 12 AMU. One mole of C20 weighs exactly 12 grams. The number of particles in one mole is called Avogadro's number. In A equals to 6.023 multiply 1023. The mole of C atoms with 12.1 gram and has 6.023 multiple 1023 atoms. The average mass of C atom is 12.01 AMU. Okay, for the example, 1 mole of water or H2O contains 6.023 multiply 1023 of H2 molecules. Mole substance equals to mass of substance in gram per molar mass of substance gram per mole negative 1. Number of elementary unit equals to mole multiply Avogadro's number. So the important relationship in this mole concept is we can see C2H5OH has the main weight of 46.007. From this, we can see that 46.07 gram contains 2 multiplied to 20.01 equals to 24.02 gram of carbon. The oxygen is 1 and multiplied to 16.00 will equals to 16.00 gram of oxygen. The hydrogen is 6 multiplied to 1.008 equals to 6.5.05 gram of hydrogen. Other than that, one molecule contains 2 carbon atoms, 1 oxygen atom, and 6 hydrogen atoms. Lastly, 1 mole contains 1 mole of carbon atoms, 1 mole of oxygen atom, and 6 mole of hydrogen atoms. So as the last for me, the example, how many atoms are in 7.7 gram of cobalt? We calculate with mole using the mole concept. 7.67 gram cobalt multiplied to 1 mole of cobalt per 58.93 gram of cobalt. Multiple to using the Avogadro's number, which is 6.02 multiply 1023 atoms per 1.00 mole carbon. The end calculation is 7.84 multiplied to 1022 atoms of carbon. Okay, that's all for me. I pass to the next person.
To our lecturer, Puan Munirah binti Muda, and my fellow friend. My name is Kamal Hazimin Kamal Zaman, and in this 2.2 mole concept slide video, part 2, I will add a little more explanation about this title, which has been explained by Amma in the previous video slide before. Okay, For this slide, I will introduce you about Avogadro number. Avogadro number has a value of 6.023 multiplied 10 power of 23 in every 1 mole of any particle, atom, molecule or ion contains 6.023 multiplied 10 power of 23 particle. Number of particle equal number of particle equal number of mole multiply Na, which is Na is a Avogadro number. Okay, in this slide, I will show you example of the question. The question is how many hydrogen atoms are present in 25.6 g of urea, and the molar mass of urea is 16.06 gram per mole. Okay, first step is we take the 25.6 gram of urea divide molar mass of urea is 60.06, that equal is 0.426 mole. Second step is 0.426 mole multiply 6.022 multiply 10 power of 23 molecule per mole, and we get N equal 2.567 multiply 10 power of 23 molecules. Next step is we take 4 atom multiply 2.567 multiply 10 power of 23 molecule divide 1 molecule equal 1.03 multiply 10 power of 24 atom. That's it. Okay, for this slide I will show you example. The question is what is the mass of 1.77 multiply 10 power of 30 molecule of CO2. 1.77 multiply 10 power of 30 molecule of CO2 multiply 1.00 mole CO2 divide 6.02 multiply 10 power of 23 molecule CO2 multiply for 44.01 gram of CO2 divide 1 moles of CO2, and the answer we get is 1.29 divide 10 power of 8 gram CO2. Okay, for this slide I will explain about mole and molar volume of gas. Molar volume occupied by 1 mole of gas at certain temperature and pressure condition. At standard temperature and pressure, or we call STP, equal 22.4, and at room temperature and pressure, we call RTP is equal 24 liter. Okay, now I will explain about relationship of mole and volume. Volume of gas is equal number of mole multiply molar volume. Example, calculate the volume occupied by 1.25 mole M2 gas at STP. Given that 1 mole of gas occupied 22.4 liter at STP. The solution is at STP, volume of 1 mole of N2 is equal 22.4 liter. So volume of 1.25 mole N2 is equal N multiply molar volume. That is 1.25 mole multiply 22.4 liter per mole, which is the answer is 28 liter. That's it. Thank you for this my presentation, and goodbye.
Assalamualaikum warahmatullahi wabarakatuh. T is another subtopic, empirical formula and molecule formula. Empirical formula is that one simplest whole number ratio of the atom of element in compound can be determined from elemental analysis mix of element formed when a compound is decomposed or that fits together to form a compound, composition analysis and percent composition. Finding an empirical formula. Convert the percentage to gram. Assume you start with 100 gram of the compound. Skip if already in gram. Convert gram to mole. Use molar mass of each element. Divide all by smallest number of mole. If result is with 0.1 of one number, round to one number. Multiply all mole ratio by a number to make all one number. If ratio .5, multiply all by 2. If ratio .33 or .67, multiply all by 3. If ratio 0.25 or 0.75, multiply all by 4. Skip if already one number. Crick timetable for calculate empirical formula and molecule formula. T is example for carbon, hydrogen and oxygen. Molecule formula. After we get empirical formula, we can search molecule formula. The molecule formula is a multiply of the empirical formula. To determine the molecule formula, you need to know the empirical formula and the molar mass of the compound. T is the example of the formula. T is the one example to searching butanedione.